CSE FDP. Today, we are honored to have our esteemed speaker, Dr. Santosh Kumar S. with us. Dr. Santosh is a senior data scientist in Eurowings Digital and holds a PhD degree in machine learning as well as MS in software engineering, both from Vellore Institute of Technology, India. With over 10 years of experience in the field, Dr. Santosh has worked on various roles, including research and development and senior software engineering. In his current role at Eurowings Digital, he works on e-commerce applications and contributes to tech hackathons that use machine learning to address real-world challenges in the aviation industry. Dr. Santosh is an expert in machine learning, deep learning, natural language processing, and social network analysis with a strong research background. We are excited to learn from Dr. Santosh's expertise, and we look forward for an insightful and engaging session. Dr. Santosh, we welcome you, sir. The session is over to you.
Okay, thank you. Thanks for the warm welcome. Am I audible to everyone? Hello. Are you able to listen?
Yeah, sir, you are audible.
Okay. Then let's get into the session first. Let me share my screen.
Yes, sir.
Okay, let's go as a slideshow. Okay. Hope you are able to see my slides. Let's start.
Yes, sir. We can see your screen.
Super. Thank you.
Yes, sir. We can.
Great. Okay. So today we are going to talk about NLP. So NLP in action, which means like we will be talking about where the NLP is used and what it is, how we are doing NLP tasks. Okay. So that's the pretty much. And I split this session into these types. And first we will start with introduction and which answers where question, and this next foundation and building model building steps. Here we will talk more about what and little bit of how, and we will spend more time here. And also like next, like some of the researchers, I mean, as I'm addressing you faculties who are part of research as well. So I would like to show and talk about some of the research that moved NLP to next level. Okay, so and then we will do some hands-on where I will be explaining how we build a model using various model building techniques that we discussed on the second step. Okay, then we will go with the closing off with challenges and future, how we can bridge the gap between academia and industry. So I think now that I set the ground, I mean, let's move to the next slide. So I don't know whether he will be able to chat. So if at all, like, I mean, any of this or all of these icons, like maybe can you tell me like what are these icons, and is any of you not using any of this? Raghavendra, we can, I mean, participant can chat, right? Chat and talk.
Yes, sir, they can.
Okay, superb. I see, 22 people. I mean, maybe let's go this way. So if is anyone don't know any of this icon? Yes or no? That's enough. Okay. Okay. So okay, then I think it's more about mono talking, like just I talk. Let's see. Okay, so all these icons like we use on a regular day-to-day basis. Like for example, the first one is Google Translate. This one is used on all the translation purposes. So now I'm in Germany. Like when I come here, like I don't know the language, so for every other day, like I've been using it, so it's so helpful for me. And similarly, the other tools like Grammarly, and the other one is Siri. The next one is Netflix. So these are all like we use on a day-to-day basis. As we are using this, all of this have been developed using NLP techniques. Okay, so all the building blocks of these tools are you on NLP. Okay, so I'll also explain some of this and how it's using NLP in next slides. Okay. And so NLP as a technique is there for quite a long time. Uh, for example, it has started in the year maybe 1940s or something. So and this is one of the tool, a chatbot, first ever chatbot, which was developed in 1966. Okay, so that time like it was used for a psychotherapist to develop a discussion between their patients and the staff if the staff is not available. Okay, that's why it started to have but this was very basic, and it is based on a technique called rule based system that also I'm going to explain in future slides. So this one as is a very predecessor, and for us to have the feel of how a computer can talk with people. That's what it is. And next is some of the facts before we talk about what is NLP. So I also want to talk about how it is placed in the current world. Like NLP's current market space is really huge with the recent advancements like ChatGPT and stuff like that. But ChatGPT is one of the application. Okay, there are huge number of other applications. So its market is massive when it comes to the future years. So it's predicted that it will be 91 billion in 2030, and we are using NLP on a regular day-to-day basis. So it powers the personal assistance. As I was explaining about Google Translate, machine translation is the most useful NLP technique, and it helps in billions of conversations. And earlier we have idea that computers don't think, whereas that's getting changed. Okay, so now NLP is getting really creative. It can give you a creative answers to your questions, and it can engage with you. That's what the recent advancement are keep going on. And the one most used application in the industry is sentiment analysis, like which is very basic in terms of NLP, but that's what the most used as well. And one of the application of NLP is language models, which is ChatGPT kind of stuff, and that is really huge. It has billions of parameters, and billions of amount is also have been spent there. Okay, and next. So as I was explaining in the first slide, there was some of the tools that I was giving you, and now I mean what and what. So virtual assistants for Siri and Alexa. So I believe some of you might have used it, and Google Translate that I regularly use, and personalization in e-commerce. So e-commerce applications widely using it now for like Amazon, Netflix, stuff like that. They use NLP to greater extent now. And Scholar C is to summarize. I mean, this is mainly to summarize the research papers as well. So you can ask it to you can upload a PDF file, or you can ask share a link. It will summarize for you. And fake news detection, this is my area of expertise, where like I've done my PhD here, like to detect fake news. But this one is based on the fact, so you need to let Snopes that this is the fact, then whatever news that comes against it, then it will be considered as fake news. And in the first slide, I was explaining about ELISA. ELISA was really a very small application that started in way back in 1966, but now there are really very good applications that's used in psychological analysis. So one of the tool is Wobot, that is this one. Okay. And next, the part belongs to you. Where does NLP help you as academic people and staff? I mean, the faculties. So Duolingo is a language learning tool where personalized learning is the game-based learning is the main thing, main theme of Duolingo. So there NLP is widely used. And Grammarly, I've shown you. So that is for now they've extended it to SS scoring and feedback as well. So earlier they were giving only for feedback. Now scoring and stuff like that is there. And Newton is a platform that is used for the curriculum development. So it can assess a student, and then it gives a personalized curriculum based on how they respond. Okay. And next one is Turnitin, who is a researcher who would have already used it, and now Turnitin is using NLP a lot. And other two like Quillance and Scholasty. Scholasty I've explained a little earlier for the summarization purposes. Yeah. So now, I mean, I showed you like what is the impact it has, and then where it is used in a for regular people and for the people like you. So now that convinced you that it is used everywhere, let's answer what question. So what is NLP? So in simple term, what NLP is, let the machine understand and respond to the human. That's all. So human would speak in various languages, whatever language, whatever accent they speak, and NLP, a computer, should understand it and respond to them. So this is really an exciting domain. That is why it started way back when AI itself was very new, like 1940s. Like AI itself was artificial intelligence itself was a very new thing, and NLP was also in a common place there. Okay, so it's really exciting for them, and that is why and the way it moved on is really huge. I will also explain you the timeline. So the next slide is talking about that. So in this place, while answering the what question, where we will be spending a lot of time, so I will explain the path NLP crossed throughout last around 100 years. Okay, and what are the fundamentals that it has, what are all the uh, difficulties it faced, and then like how it overcome all that, and at the current situation, what are the tools and libraries that we use. At the end, like the part that I belong to, how we develop model, I mean machine learning models, and what are all the different steps. Okay, let me move on to the next slide, which talks about the timeline. So it's brief. I will also explain each time frame in a little bit broader way. So 1950s and 60s were like real NLP started. So that time what people were thinking is like whenever a sentence is given, we just want to translate it. Translation was the first ever necessity for a natural language processing. So that time, like dictionary based applications were very popular. So you give a sentence and words will be identified, and each word would be synonymized, like a dictionary would be there, like, right? So synonymized, and then the response would be given. So it's all basic. So next is a chatbot kind of stick, like 1960s, like Elisa that I have explained at the beginning, and 1970s and 80s where the expert systems were popularized, where an expert would be there who would be explaining or who would be giving rules to a computer. Is anyone talking? Okay. Uh, rules would be given to a computer. Then, based on that rules, it'll answer. So that's all it is. After that, so 1990s, where the computers got really popular, and that's when the statistical models, which uses systems, and then and a little bit of smaller machine learning based models have started appearing. And then the story is totally different when we were able to have a lot of infrastructure. So language models, and more of more of neural networks, more about language related bigger applications. Now we have ChatGPT and stuff like that. So let's go one by one. So 1950s is when, like, the rule based application, I was explaining you the dictionary. So that is one of the rule based application. A1, B1, and mingle, I mean, do A B. If you say AB, then you have to say A1 B1. That's all. So simple. Then 1960s were like parsing, like uh, when you give a sentence, a system would parse and identify what a person means, then it responds. That is parsing systems. And symbolic, it also means like expert system, where
This morning all exam that is difficult.
I think, who is that? Legimol. I thought they're asking me questions. Okay. Can we mute them?
Exam will be on morning. Morning exam will be there. How you will be coming and writing the hall ticket? There will be huge rush there. All the people will be coming in you only, no?
Sorry, sir, it's muted now.
Thank you. Okay, I'll continue. I don't know whether it will be stopped. So I'll keep continuing. So if at all you have a question, call me. I'll answer. So it's 1980s when the expert systems were in place, where the knowledge is given to a set of knowledge and rules will be given to the system, and then based on that it answers. Then the real NLP that what we have now have started in 1990s, where the statistical models have started evolving, and there were really statistical parser applications, like first robust statistical papers were developed in 1990s, 95, 96, like that. So, and then the information extraction system was there, like MUC competitions, stuff like that. And there are some of the really advanced techniques like pure tagging, information extractions. Those were started being applied in 1990s, but these were all started, I mean, coined really long back. So, but they got applied in statistical models in 1990s. Once 1990s time, with the statistical model evolution is keep moving, that's when we started getting into ML, machine learning models. So here, variety of ML models, ML methods were used, like very small methods, like ML models, like logistic regression. It's very small, so you just have to do some processing, provide it, and then it'll give you a response. And then the time it takes is really very small at the current moment. But those were the founding steps. Okay, and I was explaining the knowledge base, right? So for expert system, similar kind of thing has been created, like called corpora, and that is those were all happening in 2000. There is one another interesting fact thing have started happening in 2000s, that is competitions. So the current phase where we are now are is mainly one of the main reason is competitions. Like, I don't know whether some of you heard about Kaggle. Kaggle is a famous competition holding platform. They create a use case and provide you the data set and announce an hackathon. So you participate that in hackathon, and once you win, you will get some money. So due to that, like many people have started participating it, and then provide many valuable resources, provide many valuable insights in those domains. So those stuff has happened in 2000. So that is really a building block for us, and Semeval is one of that. And during those time, even I participated in some of it. Okay, and so I could also remember that. And in ML models, like we have supervised, semi-supervised, and unsupervised. So logistic regression and stuff like that are supervised, which is basic. We also provide emphasis on unsupervised and semi-supervised during those times. And these are all basic and very small. And when it is when I say it's small, it also means like the applications that it provide, it also smaller applications. So for example, here, like some of the older applications are machine translation, that's very well, I would say, information retrieval, query answering, that is like chatbot, and report generation. The weather report generation is one of the very old application of NLP. That also I have few slides to show you that how they were doing the report generation in the older times. And next is deep learning era. This era is interesting because we moved into this era due to the fact that we have enough infrastructure. Like we have a really very powerful computers, and these computers and supercomputers, I would say, like these computers were able to handle really huge data, and their memory is really big, and then processing power is really good. That's why we were able to move to that level. And some of the deep learning techniques that is used in NLP are like mainly recurrent neural network. Part of that is like long short-term memory, which is LSTM, and some of them. I mean, I was using CNN, convolutional neural network, in my PhD, and some other applications like NLP started being applied into other techniques like image processing and video processing, where like the description of that is from NLP. So those are all the places things happen. And now we are at 2020. At, I mean, once we enter into this phase, like we got into this large language models, and now every big companies do have large language models. So, and we as industry people have started utilizing large language models in our applications, mainly for, so they already built, and for us we need some tweaks or we need some extra features out of it. So we take that model and then use our techniques, and then make sure like we will be able to deliver what we needed. Okay, so that is about language models. And other things like democratization is more about the infrastructure would be there for the very big people, but what about the normal people? So what people, I mean Google, are all doing is like they democratize some of their tools to make sure like we as researchers would be able to do it, and then make sure like we can also learn and then enhance the current state. And quantum NLP is more about infrastructure. So uh, the processing power we need quantum is like is newer technique. That is, the quantum physics is really way back there, but quantum NLP is a newer technique where quantum mechanics would be used with NLP. So that's evolving now, and maybe down the line in another 5 years of time, maybe we will be able to see the results of that. Okay, now I've completed the timeline. I mean, which means like we started with 1940s. Now we are at 2025. and the whole current state is this. Hopefully you will be able to see what it is, but I'll try to explain. These are all the different tasks. Sorry. Yeah, then this natural language processing, and then this whole part is related to language models, and this part is the different techniques that we use, that some of it I'll also explain, and other techniques, many other techniques. Okay, but yeah, I have links of it, maybe I can share that, you can also go through. Okay, so now we come into basics. Okay, so how a model, how a person, leave about model, like let's go as a person. Okay, how a person can understand a text. Okay, for a person to understand text, like they need to get used to it. That's the main thing. So for example, let's take the basic understanding here, like syntactically, if you see the first sentence, I hate spaghetti with chopsticks, whereas the other sentence is I ate spaghetti with meatballs. Both syntactically same, but both means different, right? With chopsticks is like they use chopsticks to eat that, whereas with meatballs is one of the food. Okay, these two are two different things, but syntactically both are same. This is little difficult. Only if you understand the context, you will be able to understand. Then next is bank. You can read it like I deposit money in bank and then I sat on the river bank. Both are two different things. And the third one is like another traffic jam. This is exactly what I needed today. So if you, I mean, earlier times, 2010 and stuff time, like if you give this sentence, a sentiment analysis tool would tell this is positive, and more or less as a text it is positive, but this says, I mean, this is negative sentiment, right? So yeah, this is how it is. Like understanding a text needs a really good experience. This experience has to be built. Okay, let's go why understanding is very difficult. Let's answer that question. Okay, because I mean, and language is very extremely rich in structure. Okay, and it's all ambiguous. Like for the sentence, like sarcasm, it's so ambiguous, and one sentence mean many things. Also, many sentence means same thing. The other way also is true. So when one sentence means many things, it can be with various uh, like levels, like lexical level, syntactical level, and even the contextual level, and interaction among different people may not be clear, so then understanding is difficult. So these are all the reasons why making NLP a really robust system became very difficult, and how people started resolving these is what the next slide is. Okay, this is only very few examples where I'm explaining about how the ambiguities were tried to resolve. Like these are all the techniques, but sometimes out of these techniques also ambiguities would be there, and we cannot resolve it to some extent. And now we got so much matured, but these are all the main techniques. One is part of speech, deciding whether a duck is verb or noun. Okay, so maybe I'll explain you with a sentence in the next slide. And then word sense disambiguation. Oh yeah, make, where you put makes it whether create or cook. Okay, syntactically, yeah, I saw the man with the telescope. If you see this sentence, this telescope can belong to I, the first person, or the man. Okay, I was with the telescope when I see that man. That also can be a meaning, but I saw the person who was having a telescope. Okay, kind of these are all the thing. And this kind of disambiguation can be resolved with the probabilistic parsing. So that kind of parsing happens with word to vector like that. Or those slides are there in the future slides. Okay. Yeah. Then let's go to next one. This is POS tagging, part of speech tagging. So where we tag. I think this during our English lessons we would have learned it, subject, verb, object, similar kind of thing where here we need to tag it based on where it's placed and then what it means. For English, yeah, so based on our structure, it is a bit of I would say little easier, whereas for the other languages like our South Indian languages, it's really difficult. You can place a word anywhere you want without disturbing its meaning. That is possible with our South Indian languages. Okay, so when such things happens, it's very difficult for a machine to identify where noun is placed and where verb is placed. Okay, so to resolve such things, we have various algorithms, various techniques, and some of that, like I've explained, I've added here hidden Markov model and then Viterbi algorithm, where it passes first, it creates the passing tree, and then based on where it's placed, based on how it affects the next one, the tagging is given. So when you add an algorithm, or when you add when you start with natural language processing, this is the first ever step where you first split your whole sentence, make sure it's there in a proper order, and then the position is clearly mentioned. So the POS tag, the applications of it. Next, we'll talk about the applications. So some of the applications are name entity recognition. So when you provide a sentence, you need to know like what entity it talks about, whether it's a place or it's a person or it's something else. It has to tell. So POS tagging helps there, and then for question answering it helps, and chatbots, it's really helping huge. And for us, like the earlier in the earlier slide, I was also explaining about word sense disambiguation. Here also part of speech helps. Okay, yeah. So this is one of the important technique which was developed in 1940s and 50s. Okay, and have been used even now. I think I've answered what question so far. Hopefully, like no one asks question or so far, right? Yeah, I don't see anything. Then let's go to next point. Okay, now I'm going to talk about how part. Here, how NLP works, and then its own basic concepts. Yeah, honest. So this is the structure, like NLP structure. Yeah, once again. So first is natural language understanding and natural language generation. So think as a human. So when a person talks to you, first you need to understand what they are talking, then you will respond. Similar thing is what a computer has to do, a machine learning model has to do. So natural language understanding first, then generating the response. So these two are the main building blocks, and natural language governance has been in a similar order but similar importance. And this governance involves ethics, bias, like you should not be so biased on particular set of people, and legal aspects. And in Europe you cannot, expose personal information really very easily. So it's very difficult. There are very strict rules. Such things are covered here. So such things, when you develop a model, you should also think about, you should think about this first before you think about the solution. That's how the world is evolving now. So natural language governance is very important when you develop understanding and the generation. Okay. Then what I'll do, I'll go through first two, natural language understanding and natural language generation. And while I'm explaining these two, I will also give you some hands-on. I will also show some tools which uses this. Then we will talk about natural language governance. First, we'll go to natural language understanding. Yeah. So what it is? So mapping the given input in the natural language into a useful representation. So computers, right? So again, I'm going to the computers. So computers don't understand words. What they understand zeros and ones. So what it means is like they need different representation for the representation that we have, and we don't understand zeros and ones, so we need different representation than computer has. So vice versa, right? So first thing, so our natural language has to be put into a useful representation. This is there are various ways. One is syntactic analysis. This is more of a position tagging that I explained earlier. So subject, verb, object. So you just split it like here. The doesn't signify much. Okay, so it comes with cat. Okay, the article comes with the cat. So this is subject and main subject is this. Okay, so you need to discard it, or you need to combine that with the cat. So such understanding should be there. And next is semantic analysis. The bank, again the bank example. So in the first sentence it says a financial institution. In the second sentence it says riverbank. Yeah, this is semantic information. And next one is the other technique for the natural language understanding is like named entity recognition. So in this sentence, Apple Inc. was founded by Steve Jobs in California. So Apple Inc. is an organization, Steve Jobs is a person, and California is a location. This has to be tagged properly before you proceed to the next level, so that like the meaning should not be changed. Okay, and then recognize what intent the particular sentence brings in. So for the first sentence, it says flight booking, and the second sentence is more relevant to the weather inquiry. Okay, so now that I've explained you the four techniques like syntactic, semantic, and named entity and intent recognition. So these are not the only techniques for sure. Okay, and these are the first basic techniques, basic steps for any person, any machine learning, any model to understand the natural language. And I explained in English. So same goes with different languages also, and different POS tagging. So different kind of positional tagging should be applied to each language because each language is different. Okay, so let's get into the next section of natural language generation. Yeah, here the goal is clear, right? So goal is, so when internal representation is given, you need to provide a proper natural language as an output. That's the main goal here. So for that, various techniques are there. So the very basic technique is this template based NLG. So this is a JSON structure. Sorry. This is a JSON structure. So JSON holds some information. Okay. And this gets converted into this one where like the location is put here, like today's weather in dash is dash with a temperature of dash. That's how a template would look like. So each dash should be filled with the information in the JSON. That's all a template based and natural language generation is, like very straightforward. It just have to have the proper mapping, then it will fill and then give you the answer. Very simple. This is what used for a very long time, the beginning, until statistical models or statistical techniques were come into place. If you see the next one where the statistical analogy is, you still see the same text like New York temperature and then the condition, but here the one tricky thing is, like on difference is, like here the tagging is not there. Like we are not saying to the application that New York is a place instead of a weather condition. So the statistical analysis should understand New York is a place, 22 degrees Celsius is the temperature, and partly cloud is a condition. Okay. Once it understands this here a bit nice thing is, like you don't have to tell it what sentence you want. It can generate different sentences. You can see, right? So there are 3 sentences has been developed using this technique once it identifies the different parts of the input. So that's really interesting that it can do itself. Okay. And next technique is, I mean, again, this is another easier technique, like the template based, where here one more rule would be added. Here the rule says, like, if the temperature is more than 20 degrees Celsius, say warm. That's all. So when it is 25 degrees Celsius, it says warm. Like these rules can be added. Like this is more like the expert system that I was explaining you a bit earlier. So, but now so these are all like very basic one. So statistical rule and then template based are basics. Now many things have been advanced. So once a deep learning based natural language generation have put in place, so these rule based techniques were replaced, because it itself, like over the time with various inputs, a deep learning model itself can understand what rule it possesses. Okay, you don't have to tell to an application. That's why it's machine learning. Okay, so it itself understands it. Okay, and yeah, so as I'm explaining you natural language understanding and generation, understanding is really difficult because it is more ambiguous than generation. So, but if you see, both are really, really difficult. Okay. Now let's go back to the first slide. Yeah, I've explained understanding and generation. Okay. I know there won't be. Is there any questions? Okay. Then I'll ask. The last part is like, how do you build a model which understand and generate the required text? Let's go with model building techniques. Okay. This is really another bigger part. So it starts with the required data collection. So what is data here? So any machine learning is like you give examples to it so that it learns, and similar when similar situation comes, it respond to similar to the example. That's the machine learning technique. So for that you need similar examples. That's where the data collection part is. Then text would be containing so many unnecessary things. For example, so many extra characters or some punctuation marks, stuff like that. Those needs to be cleaned and then processed. So this is called text cleaning and pre-processing. Then feature engineering, that is like feature generation part that I'll explain what it is, but generate the feature so that a machine can understand what feature it holds. That's what feature engineering is. And develop a model, evaluate what it is, and then whether it's performing well or not, then deploy and start using it. That's the different steps, and we'll go step by step and then see what each steps holds, what are the different techniques that we use in each steps. Okay, let me go to next step. So first is pre-processing. So here raw text would be given. So this is the flow chart. Raw text would be given, and then first it will clean it. Cleaning is like removing special character, converting it to a lower place and stuff like that. Then tokenization is making it token. Token is nothing here. Like if you see it, when hello world is given, it will be tokenized hello world and then the exclamation. So word by split, and any special character would be split outside. Okay, so that's what tokenization. And then you need to lowercase also, that is in text cleaning. And stop word removal. I was explaining about a text, right? The cat sat on the mat. So the cat is like is an article which belongs to cat and doesn't signify much instead of the like. So that we call as stop word, where it doesn't signify much but it will be there the whole text. Okay, so the would come in many places. So the and stuff like that. Okay, those needs to be removed. So those we call a stop word. And stemming and lemmatization I will explain in the next slide, and normalization. So lemmatization and stemming, it's another important pre-processing technique. Like if you see the example, running in a text, you will have running, and in other place you will have run, and but both means the same. Whereas this is present continuous, where this is present. We need to make sure running means the same run. So we will lemmatize, like we'll remove ning and make sure it is run. And stemming is little extra, where so you would also make runner as run, so that like it goes back to its root word. For running and runner, root word is run. So it has to go back to the root word so that like our processing would be a little simpler. And then make sure like the meaning is intact. Okay, so these are the pre-processing technique, and then you need to vectorize it. So for vectorizing, I will explain in the feature engineering part. Yeah, let's go next. Okay, so now that I think I need to go to the previous slide. Now that we finished these two, I'll explain what is feature engineering. Yeah, there are various techniques in feature engineering, and I'll start with the very simplest technique. This is called bag of words. As the name says, a bag of full words. Like you split all the sentence into words, and then create a vocabulary set like this, and after that create a matrix that contains all the sentences. In this example, if you can see, I love to travel, traveling is my passion, and this gets split into a vocabulary set called I love to travel and traveling is my passion. So all get split and then come into this side here, sentence 1 and sentence 2, the full vocabulary set. And if at all, I mean, there can be one thing, like if at all the pre-processing are be done, traveling and travel would have become only one sentence. I mean, traveling would have become to travel, and then there will be one entry in this table. Since the pre-processing is not there, so traveling is is a separate word compared to traveling. And so you can see travel is there in sentence 1, traveling is there in sentence 2. So, and this matrix with the 2 column would be sent to consider as a feature. Okay, and this is for the mapping. This will be obviously removed. Yeah, this is first technique, easier technique. And but the one tricky part here is like here we don't keep any context here. So if you see, I love to travel, I love to travel, like there is no context set, and all like predecessor and successor are all removed. So since it is this way, we are not preserving the context. This is not working that great. So moved on to the next feature engineering technique called n-grams. Here, like sequence of n consecutive. So n-gram means like, I will take the same example of I love to travel. Here, when you call it as a unigram with 1 gram, you will you'll split into each word. But if you call it bigram, then I love to travel. So it's like first two, second two, third two. So like this it will be split. So so like this it can keep go. So generally we use till trigram. We don't go beyond that, but it can also go. Uh, in this sentence, like it is little better than the bag of words. Reason is the predecessor somehow would be kept intact. Predecessor and successors of each word is kept intact in one or the other way. The unigram is similar to bag of words, but still after that bigram and trigram. So as it is kept intact, the context is also is available, and we would be like going. I mean, the feature would be of providing some value. Okay, that is why n-gram is bit better than bag of words. Next technique is TF-IDF. Okay, so I think it's been 50 plus minutes now. Can we have a bit of break now for 5-10 minutes and come back and continue? Where is Raghavendra?
Sure, sir. The participants, we
Let's do
shall
this
have a
way.
now.
Yeah, let's do this way. Like every 50 minutes, like we have 3 hours, right? So
Right.
maybe for every 50 minutes, we'll spend some 10 minutes of break, so that
Sure.
like people can really listen. If they are already sleeping, they can get up and refresh and come back for the next sleeping round.
Sure,
Sure.
sir. What time shall we gather back?
Next 10 minutes. Is it fine?
Sure. The participants, request you all to get back to the session by 5 p.m. Would that be fine?
It
Right.
should be good.
Let's continue the session at 5 p.m. Request all to take a small break.
Shall we start?
Yes, sir, we can get.
Is 10 minutes over, or we can wait also? It's fine.
It's over. We can get started.
Superb. Okay. We can do it. Give me a second. I'm trying to find out where it is. PowerPoint. Is my slide visible now? Can we start?
Yes, sir, it's visible. We can get started.
Okay, superb. So before the break, we were talking about model building pipeline and what we finished pre-processing, and we were talking about feature engineering. We spoke about, in feature engineering, we spoke about bag of words and the n-gram. Now what we are going to talk about is TF-IDF. It is, what it means is like term frequency and inverse document frequency. And it has its own formula here down. I don't want to explain the formula. Instead, I would explain it with an example here, like an example which relates to you more, like a librarian searching for the most relevant books on particular topic like space exploration. So generally how a person would go and find it, like, so out of thousands of book, maybe some 10,000 plus books in the library, book related to relevant to space exploration would be hardly around 10. So it would be like, it will be rare in the whole library. So first, rareness across the whole library would be found out. So which contains the important word related to space exploration. All the books that contains important word related to space exploration would be found. That is rareness. Next step is to, in that rareness, like in those 10 number of books, there will be multiple words related to space. Okay, so I mean, so much words would be there only in those books. So popularity within the book. So say for example, some 15 books are there for space exploration. So you need to prioritize based on how a particular is a single book contains how particular words related to the space. Based on that, it will be identified. So term frequency, which talks about the popularity or the frequency, and inverse document frequency is talking about a rareness. So this particular feature talks about both. That is why it's very important. So, and in various experiments, this feature, I mean, this is one of the features that's for sure, but this feature performs better than bag of words and n-gram and stuff like that. And apart from this, there are many others, so I'll explain those. But with TF, we'll do an experiment, or we'll do an experiment between bag of words or n-gram with TF-IDF and see how it performs, and that during our hands-on. Okay, so the next topic, next feature engineering technique is like word embeddings. So here I've explained about glow. So if you see the relationship, the concept here is like, the embedding concept is like keeping more relevant or more similar words in nearby places, or in a matrix, like you keep it so near between these two. So For example, here semantic, if you see queen and king are similar, would be in the nearby places, and in the syntactic way, like big, bigger, biggest, and small, smallest, like these would kept nearby. So this way, like we will make sure that the meanings are so by keeping the words nearby, meaning of the whole context would be kept intact, so that it provides more proper feature compared to anything else. So word to work is like commonly used one, and glow is also performing better. Fastest fastest is to find out the topic out of the whole text. For example, you give the bigger document and find out what topic this document is talking about. Then now in those scenarios, fast text is used, um, and for the feature engineering purposes. And these are all the powerful one compared to remaining things. So if you see these, and back of words is really no much technique involved. Here a bit of technique is involved, and whereas TF-IDF is more of uh, the calculations, mathematical calculation and stuff. And after that, word to work, glow and all like involves more of a statistical model. And then word to work is one of the pre-trained model, which helps in like so much words are already pre-trained, and then that model is like, I will explain what is pre-trained in the future slide. So it's one of the pre-trained model, basic model, embedding model that is used for the feature engineering. Yeah. So with this, I think we are done with feature engineering. So pre-processing, after text cleaning, pre-processing, feature engineering done. And then after this, the next main part is building the model. Okay. So to build a model, like I was explaining you in machine learning, so we are providing examples to the machine and see, I mean, make it learn, so that when similar example or similar, if you put the model into the similar situation, it respond to how it responds to the existing examples. Okay, so that's how a model gets built. So for that, you need to have, when the data set is given, to make it testable, you just remove few of the data outside, so and train with the remaining data, so that like you can test the model how it works. Okay, so from the examples itself, that is called train and test split. Then there are so many models there, but some of the models we will use as a base model, so that like whenever you evaluate a model and see whether it is working properly or not. Like for example, logistic regression is one such model where we will be using that as a base model. The reason for setting a model as base is like, you know how bad a model can perform, and then keep that as the benchmark. Below that, it should not go down. That is the base model selection. So I mean, this is on an average how a model can perform. That's all it is. Okay, and then like you need to evaluate with some technique. There are various tons of techniques involved to evaluate. So some of them are like accuracy, recall, precision, and stuff like that. For NLP also similar kind of techniques are there, like map and stuff like are there. But yeah, you need to also select the proper one for every testing or every model building. You cannot use the same evaluation metric, because all are different. So you need to identify which one is better, and then to use in the given scenario. After doing all these three, you train the model with various different algorithms, model building algorithms, then find out which one is better by comparing it with the test, and then finalize the best model. So the last step is what very important. The best, you need to say why it's best, and based on the various evaluation methods. So by doing all the steps from train, test, split to finalizing is what the model building is. And for to do all this perfectly, you need to have pre-processing and feature engineering in a good shape. Okay, so these are all like combine together to make a better model. And the next one is evaluation. As I was explaining, like you select evaluation method here, but you do evaluate here to find out the better method. So evaluation comes at the once after you do the prediction and find out how it performed. And mainly like earlier days, like 2010 around that, like you once you evaluate, you find out the accuracy and you go away, and you don't even interpret why the particular result has came. So but now the explainability is more important, like why a model performed the way it performed now, and then what are all the features are are giving that such output is. So feature importance is playing major role in these days. So we have to find out which feature is contributing to the model performance and which feature is not, and then why it's not performing, why it's performing, all the reasoning we need to find out. So this is another important step to make sure like we are doing the right thing now. And then if the feature importance identifies that particular feature is not giving a perfect result, but we know from our experience that this feature is really important, then you need to do proper feature engineering. So it means like you didn't do the feature engineering properly, right? So then you go back to the feature engineering part and come again to all the steps back again. So this is more of a trial and error that we do during our research. Okay, so it's more or less same, but with proper data backup. Like you need to know, you need to tell like why you are doing error, trial and error, and in what phases you need to do the same. So that's the main advantage of evaluating it. And once you evaluate and identify a model is fit, it's not in there. Okay, so you need to also think about continuous evaluation. This continuous evaluation is like integrating and make sure like in for the when you are given with the real world examples, say it started performing the let's take an evaluation method as accuracy. It is the a model is accurate for 90%. Okay, and it's giving proper results first few months, it's fine, and after 11th or 12th month it started providing you the accuracy of 98, 99. That also is not right. And if it is giving accuracy of 75, 70, even that is also not right. So if it is doing these two things, it means something has changed. And as a evaluator, as a machine learning model developer, you also need to identify why it's changed all of a sudden now, which went from 85 to 90 to 99 to 70, or these two ranges. So there could be some reason around it, you need to evaluate it. So that is why continuous evaluation is another key factor while you develop an application or a model. And with this, like you here we place monitoring tools. There are tons of monitoring tools available, so in place, and make sure like our model is performing really as expected. Okay, so with this model building pipeline is done. So these are the main steps. Maybe I'll go through, since it's little bit important, I'll go through each steps. I'm not going to explain further, but this is how it is. Like I'll again show that. So it starts with data collection and then cleaning and pre-processing both together, and then feature engineering. So this is pre-step for model building, and then you build a model, evaluate it, after that deployment and then monitoring. So this is model building technique, evaluation and modeling, and this is post step for model building. So as as much as pre-step is involved, importance, even the post-step is also very important. We need to consider this also in a regular basis. Okay, so as this is done, yeah. Sorry, I'm going up. from now on, like I'll be showing you some hands-on, some tools and stuff like that, so that like you will also understand what we are using and how we are using in NLP. So now I'll introduce with some of the libraries that is predominantly used in the machine learning models, mainly for NLP jobs. So the first one is NLTK. This is more of a very flexible uh, tool or library that is mainly used for the learning purposes, learning and the research purposes. So, and SPACY is the next one. This is used for the production grade applications, mainly due to the fact that it is fast and efficient. You can also generate API out of it, and so it's easier. And next one is Stanford NLP. As the name suggests, it was developed by Stanford, and this is also again used mainly for the learning and the research purposes. The advantage of Stanford NLP is it supports multiple languages, and then so many. I mean, they spent really a good amount of time in developing this library. That's for sure, because the linguistic analysis is of really good quality, and then language support is also really good. So you can consider if at all you do research, NLTK or the Stanford NLP would be your go-to. That's what I used NLTK a lot. Okay, and this is a smaller idea that what use case you take, what kind of library in hand. So in this case, like for the first one is like for the research and the learning purposes, you go with NLTK and Stanza. And for the production grade stuff like Spazzy, there is a company called Hugging Face. They develop really good models and then tools. So Hugging Face is another go-to place for production ready applications. And then this is another use case where the topic modeling is involved. Like I've explained fast text a little bit earlier. So GenSim and fast text can be used for the topic modeling purposes. So with this, like I'm more or less done with talking. So I can after this little bit of talking is there, but more relevant to what you are doing on a day-to-day basis. So next step is like I would want to show you a bit of demo on a simple chatbot. Okay, so let me stop sharing and share the other one. Do you see my screen? What screen are you seeing now? Okay. What about now? Superb. Superb. Okay. I'll go back. So now, since I've shared you the Google Chrome, so the Teams is also on the Google Chrome only. So please, like, if at all you want to say something, and if I ask questions, like, please answer with answer. I could not see the Teams. Okay. So first we'll go with simple chatbot demo. Here, before I even go for the chatbot demo, I will show you what data I'm going to chat with. So for example, this is input, this is response. So for greetings, if someone says hello, hi, hey, any of these, and then my chatbot should respond with these three: hi there, hello, hey there. And if someone ask for name or anything, these, and then like my response, my chatbot should respond with some of these answers. Okay, very simple. Okay, so that is, again I'm going back. So were you able to see my data where I was explaining? Okay, now I'm going to chat with it. So, okay, it's running. So this is the chat file that I'm using. So what I do, I use NLTK, and I'm using different modules also, initialization modules, and then like I tokenize and stem it, use it in my prediction response generation part. Okay, and my data is this. With that, wait, maybe I'll stop the kernel, start it. Okay, let's start chatting. So first, what shall we say? Like, hi. Yeah, I would say hey, hello. Yeah, with similar words, it finds out that when I say hi, it says, so as per the data, whatever you say here, it says some of the answers here. So maybe howdy. Let's do that. Howdy. Yeah, it takes some of the answers. Now let's get back to the next one. So some of this name, or what's your name, or something like that. So I'll say name. It says
We are
God.
not able to see the chat dialog that you're doing. We can only see the Jupyter Notebook interface.
Thank you for responding. That's what I was thinking. So since no one was able to answer, I thought it's there. You are not able to see it. Thank you. I think maybe I'll stop sharing. Then I think I'll have to explain everything further. It's not tab, it's window that I need to share. Okay. I think now you would be able to see. Now you are able to see all my tabs, right?
Yes, now we can see all the tabs.
Okay, so then I'll have to explain everything further. Okay, let me stop this then. Okay, so there are 2-3 in these notebooks, like in our demo, I have some 2-3 demo. So first is very smaller one, chat. The next I will also explain about chatbot, which is more relevant to transformers, that in future, and we will together do hands-on. I mean, you just at least little bit of talking is needed while we are doing this, but I'll explain one by one, and we will do together, and that is sentiment analysis. So now the first thing is chat, and so I'll show you the data first, which is this. For each input, we will have a response. Okay, so input and response are two. So for first input, and then the responses are this. Okay, so if you say hello, it answers with some of this. Okay, and for name, if you ask about its name or any name, it will answer with this. Okay, any of these answers. It's not just one, it's any of these answers. If you go to the Python code that I use is this. So I'm using NLTK, and in that tokenizer and then stemming that I've explained you in the slides. And then like we use the response generation here. Hope it's not Latin and Greek for you. But if at all your questions, just stop me, then I can answer. Let's run this. I will stop the kernel and then start so that it starts from the beginning. So from chat, yeah, I'm importing this chat, the whole chat, and then calling the function chat. Okay. Okay. It says type exit to end the conversation. Okay. Let's, as usual, start with hello. And I'll start. I'll say help. Yeah. When I say hello, it says hello. Hey there. Help. Like we did not instruct it to do anything here. So in those cases, I'm sorry. I don't understand. That's what it should say. Yeah. It works as expected. But when it comes to the other good part about NLTK kind of stuff is they also infer. Okay. So for example, I'll explain the name part. So it says name. Then what is it? What is your name? And I'll ask what is your name? Same. But what do you think about if you ask what is my name? It'll say the same. It infers. So this is the only data that we have, and it's more or less matching. Okay, what is your name and what is my name is more or less matching, and also the keyword is name is there, so it'll answer with something from here. Okay, then again I'll go with your name, my name, just name. Yeah. So whatever you say, though you give instruction to use only this, but as we are using NLTK, so which infer stuff, it can also answer with many other combinations also. You just have to not say anything like now we didn't instruct it to correct the spelling. So then in these cases, it'll simply say, I don't understand, because we did stemming and pre-processing, only two things we did. So that's why the simpler thing would take and then do some inferring and complete it. That is very simpler chatbot, very simple and end. So again, I'm going back to the code and tell you what we did. So we tokenized and then we used stemming. Main two techniques, not much other. So only pre-processing we did. We didn't do any other techniques. Okay. Now with this, I'm going back to the slides again so that we will continue there. Again, stop sharing, screen share, window. Presentation. Yeah. So any questions here? Otherwise, I can continue to the next one. Okay, no questions. Then we'll continue further. In model building techniques earlier, what I was telling you, you build a model, you create a new model from the scratch using these techniques. But there is one other technique called fine tuning a model. Okay, where there will be already existing model. You can use that and fine tune with your existing data, with your data, and then make sure it works really well. How it's possible. So for that, this technique is used. Like there are 2-3 techniques: transformers, pre-trained, fine tuning, all that. So I'm going to explain those techniques before we talk about that more. Why I'm talking about that now, because like I'm just explaining you the basics of NLP, but why transformers and stuff? Because now transformers are playing huge role in these days. Like people are really not creating models from scratch now. Reason is the languages are huge, and the basic structure of a language contains so much ambiguity. So any model should have the existing knowledge and then incorporate the domain knowledge to make it really work better. So I take an example of humans. So for us, when we were children, when 1 year, 2 year, like that, we were taught with languages. Okay, we were taught with each word, and then we learned, we grow, and then we went to college and then finish it. When you go to the work and we want to learn a new domain, that time domain experts or domain words, jargons were taught. Just those were taught, but the regular languages were there. So which means like you, when you consider yourself as a model, you already have learned a lot as a model. Now you are just learning finance. For example, finance, and then make your knowledge wider. That's all. So where like you perform really well. For if not, if such scenario is not there, like you are only learned finance, you cannot go and talk with other people. Like only finance words you will know. You will not know anything else. These are the cases are where like transformers were introduced. Okay, so I'll explain you transformers. And the interesting part here is this was developed in 2017 by an Indian who worked in Google. He is also a researcher. Okay, so in a group of people, the main author was an Indian. So I'll explain this paper also in further slides. But let's go into transformers. Transformers is a deep learning model. It The main purpose of this is to handle the sequential data, the natural language, yeah, the sentences and words, documents, everything. So anything that is sequence. Okay, so it consists of two, as I was explaining: natural language understanding and then the generation. These two. Here other techniques are, like if you see this, like main other techniques is multi-head attention, and then feed forward, and masked multi-head attention. These are all the important techniques involved in these transformers to make sure it really be robust. Instead of being perfect, it is robust to handle any scenario. Positional encoding is also another important technique that is involved here. So I'm not getting in deep depth with each techniques, because that makes this explaining this paper, which may not be that suitable for the basic understanding of NLP. So let's go with two main parts. One is encoding, where natural language understanding is involved, and then decoding, where the responses are involved. Okay, and it is deep learning based model. So once you create a transformer, it means you provide it with so many information, and then transformer is ready with the existing information, and for you to use as a fine tuning method. So let's go to the next one. That is pre-trained model. So now we have transformer. You give all the data that the human example that I was telling you. You give all the existing data which is available over the internet or the web, and make it understand everything and make it more robust, that all the normal stuff it can handle. You need to go to that situation. So some of the examples are that, like that's what called as trained on large data sets before being fine tuned. And some of the examples are word embeddings, like where I was explaining you these three: word to word, glow, and fast text. I think I'll also explain about glow to you, because that's also a really good paper. And then next is the other models are like contextualized embeddings. That is T5. T5 is mainly used, and BERT. I will explain this paper as also. BERT, GPT, T5, and stuff. Okay, so you pre-train with the existing whole big language, and it's available. Now how would you fine tune? Fine tune is like take it and adapt it to your specific task. Why we do is like we have large corpus knowledge already, and we need to tailor it to our narrower task. Benefits, as I was explaining, it's more efficient and perform really bad, and the other cost is really less because it has reduced training timing, and the cost is really less. Provided transformer is cheaper. Okay, and the performance is mentioned here. Like if you see training and then the performance, it starts with the year end. So when you start the scratch, you need to start from here. Whereas with the fine-tuned, I mean pre-trained model, you'll start little higher place. The performance would start becoming better and better from there to go to really better shape. Okay, that's why we go with pre-trained model and all that stuff. Okay, then we'll go with the another demo. In this case, I will also, but now I will show you again the code. But in this time, I'll show how the learning also happens. Okay, so I'll stop the sharing. Is sharing stopped? Okay, I don't know. I will share again. Okay, what are you guys seeing? Are we seeing Jupyter Notebook or no? Am I audible? Oh man, am I not audible? Did I lost you guys? Okay. You are audible. Okay. So what are you seeing? Maybe you can tell me. You are you able to see my notebook? Are you able to see my notebook? Yes or no? Okay. Yes. Cool. Okay. I'll go to the chatbot transformer build first. So as usual, I'll explain the data first. It's this very big data question and answer. What is the separator? Is it tab? Yeah, it's tab based. And for your information, this is not the model that I developed. It's from some GitHub, some already developed one. So I'm just taking it for to explain to you. Okay, so only this one. The remaining we'll do together, but this is to explain to you. So there are many questions here, and its own respective answers, but the questions are really huge. Okay, and let's take few of the questions and then see how it performs. So for it to be doing it, yeah, this is transformer based model for chatbot. I'll go these steps pretty quickly, so we don't have to go in depth because that's really too much. Okay, so we are using something called torch here. That's also another deep learning based model technique, and then other tokenizing technique and reading the data set. I was telling you about multi-head attention. that is which is main part of your transformers. That is this one, and then feed forward, encoder and decoder. Encoder would read and decoder would respond. And positional encoding is the main thing. So the transformer would contain all of this: encoder, decoder, position encoding, all of it. Okay, so these are the position encoding, encoding, decoding. That's the step, which also involve remaining stuff. Okay, and here is where we set the transformer and use it with our data set. And this is training. Yesterday I trained. Okay, so with how many? From 300 epochs, so 300 times it learned. And I also have trained with only 20 times, I think. Is it 20 or lesser? Give me a sec. Yeah. So I did with 20, 300, and simply one. So I will go with one by one. We'll load this model. So I trained this transformers with the given data set, and in order for us to save some time, so I don't want to run it, but I think I can at least run to show you the chat. Okay, now I've loaded. I will load 20 epoch, which is smaller. Let's see how this model performs. I'll say hi. We did not instruct it to answer anything for hi, so it will give any answer. See, it gives any answer. And maybe I'll take this. What was your first job in finance? First job in finance. See, it answers really differently. Is it the answer? No. So that's how it does. So when you give very smaller learning time, it won't learn properly. So I will go with something else. First job, again same answer, and then psychology should be different answer or same. See, same answer. I'll go with why did you leave your first job, or trading on New York Stock Exchange. Trading on New York Stock Exchange. Yeah, at least he started providing different results. Okay, so that's all. Like, since it's only 20 epoch, it's really bad. But even with 300 epoch, I expect it to be bad, because 300 itself is also not enough. It should take longer, but at least a little bit better than the 20. Again, I'll go with high. Yeah. Different answer. Okay. And first job in finance. Yeah. Market always involved excellent. Yeah. Trading. Yeah. Now started giving different answers. Earlier it was giving same answers, right? See, now our aim is to see how it answers. Okay, so what it answers is something different, because we didn't give any straightforward way of handling it in here. It's all like over the learning, it'll give proper answers, but we did not give straightforward answers like the earlier chat. Earlier chat, we said XY rule based. I mean, we can clearly see that it's kind of rule, where here it's learning one by one, like example based learning. Okay, so what else we can give? So okay, trading on the New York Stock Exchange, we can say that trading on the New York Stock Exchange. Superb. Stock, the Cosmopolitan Stock Company. Oh, super. Okay, this is how it is. Okay, so over the time, when you give a learning time, I mean, you need to give more data and then make it learn over the time, one by one, many times, and then it will perform really well. So this is how it is. So if you see the responses, see, with one first learning, the accuracy was just 14%. Let's see for 20th learning. 20th learning, the accuracy was 50%, 49, around 50. Okay. Over that, and the accuracy kept growing. And it went to a level where it is not increasing after that. It says accuracy as 99%, but the model is not doing that. Model is not giving such a good response. It's giving the response which is better than the earlier one, but not that great, which also means accuracy is not the right metric for this to learn. Okay, we might have to change the metric which says which measures the responses properly. So will think about something else like MOP and stuff like that. Okay, so that's how. So now in live, like what I've done is I took a transformer and made it learn, showed you two different cases with smaller learning and then the higher number of learning, and I also showed you how important it is to identify or pick a metric, proper metric. Though this metric shows 99.9, so 99.6, which is 10, it is 100, right? Though it says 100, it is not 100. So the proper metric should be there. Okay. That's it. Again, we'll go back to the slide and show you whatever I showed here one more time, and we'll go to the next one. So going back to the slide. Again, stopping my sharing. One more, I mean, another 2 times I should do. Play from current slide. Yeah. Okay, so what did we do? So we took this transformers with the various steps, and then we provided with the fine-tuning data set, and then made it learn, and then see how it works. Okay, that's what we did now. We'll with this, like the chatbot related stuff is over. I'll explain few more steps and before we go into the hands-on. I think with that, for hands-on, we'll take some break, then we'll go to the hands-on. Let's go further with datasets. So where can you take the datasets? These are the different sources. So Google dataset is really good, but for NLP task, you can rely on Kaggle. There are other places like IMDb reviews. Like we will take, for our example, we'll take something from IMDb reviews, and then there are some Square, and there are many competition providers who also provide the data sources for our learning purposes. So for my research, from my experience, I'm saying for my research, I took data set from Twitter, Facebook, because I've done fake news detection, which needed data sets from the social network. Okay, so that during 2013, 14, 16, 17, those were the time I was reading Twitter and Facebook. They were a little bit free by that time. Like free, I mean like they allow you to take more data from them and then learn. Now there are many restrictions involved, but still Twitter is providing us the data, so you can rely there and then get the data for the research if at all you are doing some NLP research. Twitter is really a good place to take data. Okay, yeah. And this is the part that I really wanted to show you, because you are more of a faculties with research involved. Here I'm talking about a few of the researchers that have moved NLP to a different level. For example, it's going in one direction and a new research come in that makes NLP to take few leaps further, like 10 steps further, 20 steps further very fastly. Okay. For that, so many researchers helped, and some of the researchers really changed, I mean, made us become as a trendsetters. So I'll talk about those now. Okay. So these 4-5 are really one of them. So I was talking about transformers here, which was developed on, whose names was Fani. Okay. And this introduced the transformer architecture. And BERT is again another transformer, but it is like bidirectional. Okay. So in attention, what it does is like one side, encode, decode. Whereas BERT, it bidirectionally encode. If you give one sentence, it start from starting, the other start from the end, and then read. So that's what bidirectional. And then other are neural probabilistic language model. This is a neural network language model which is used now. And then sequence to sequence. Then GLOW is now main of a, this one is more of, I mean, I've explained a little earlier also. This is more of word embedding, feature engineering technique, which helped. So earlier, like the path it moved is like feature engineering is like bag of words had no context available at all, and ngram had little bit of context. TF-IDF had context of whole document and then the particular line, particular sentence, like whole library and then a book kind of stuff. And this GLOW is more about co-occurrence, like it has the context of the neighboring text and the whole document. This went little bit further. Okay. And it works really well, and I will also explain that. Let's go one by one, maybe 2-3 I would explain out of it. Okay. The first one is attention is all you need. The important ideas are attention mechanism, where it pays attention to the importance words. That's what attention mechanism is. Positional encoding is to like incorporate the context. So okay, so for example, a word comes as a verb comes as a subject, I mean next to subject, is different from comes next to object. Okay, so the one comes next to subject in terms of English, I mean one comes next to subject plays higher role or higher importance than one with the object. Okay, so that's why like positional encoding is important, which keeps the context. And next is encoder decoder architecture, which I have already explained to you. The main advantage is like it can parallelly process, and then the long context is preserved due to the positional encoding and feed forward technique. Okay, and with after introduction of this paper is when large language model idea emerged. Okay, so the whole large language like ChatGPT, DeepSeek are based on this transformer technique. Okay, so this paper really set a trend, and then it changed the whole NLP world. Okay, and my research was just before this, so I was using CNN. Okay, bidirectional encoder representation from transformer. So this is little bit of a game based application. So when I read this paper, I was really thinking like a game. So what it does is this takes the whole sentence. This is going to be so long sentence, and it learns it first and then mask one of the word, and then make the learning that it has to identify which word has been removed and then what that word is. Until it identify the whole sentence, this masking and identifying the word would keep happening. Fine-tuning stuff would keep happening, and then make the model would be more robust, that whenever you give a sentence, it gives proper answers. So such a technique is this, and then it reads from top, also from bottom. That's why it's bidirectional. So and I was explaining the masked language model, and then it is so main purpose of this is like, as I was explaining, the sentence prediction, the word prediction is the main thing of this model. So it also helps to identify the next sentence prediction. The context is always aware, and then the relationship between words is really preserved, and then it gave a greater impact there. And next is glow. This is word embedding. This is the feature engineering technique. So I was explaining the word to vec. The slower would be nearby, right? So then shorter would be nearby. That's what word to work is. This is also same, but this co-occurrence happens at the whole word, whole text document level. So global level statistical information is always preserved. And then the co-occurrence matrix, like this is the co-occurrence matrix of the text, and then the co-occurrence matrix of uh, document is also preserved here. So that's why this word embedding is a bit better than other TF-IDF word to vec all. Okay, and yeah, that's what it is. So with researchers, I'll stop, then maybe we'll go for a break, then we'll come back. Okay, so what are the opportunities in the research? So in with other AI disciplines, integration with other AI disciplines is really growing. It's already there, but still growing. So image read words. Now Google Translate can read from images, right? So all the words from images and then translate. So it's still evolving, but it's doing better, but it's still evolving that there. And then like video NLP, and then read the video. Like now with recent advancements, like if you upload a video to an AI model, it can provide you the transcripts. Okay, such improvements are there, but lot other places like integration is needed, but that is being improved. And then cross lingual NLP, and then knowledge integration is another opportunity placed. And task specific pointing, like you have transformer which is about a particular language, and now we need to have this in many places specific to our task. Like for me, in my research, I could have used it for the fake news detection. So I could have provided more, and then I could have fine-tuned in a different way if at all I had it during my research. So that is one thing. And then I was explaining about this explainable NLP. This is to for example, a model is given. I mean, the performance is really good, but we need to know why it's performing that good. We need to explain it, explain so that like we can provide more enhancements. So in the research, explainability plays a really major role. Okay, so if at all we place some importance here, this is really a good opportunity placed. But what are the challenges here? Like, yeah, so many languages do not have resources. Like may resource what I mean is like we cannot even type many languages in the system now, computers. So it's growing. All our South Indian languages are able to be typed and then like processed. And we also have research in many languages now, but slowly growing. It has really a huge potential and challenge as well. And dialogue system conversational AI is also another thing. Like make it available for the regular conversation. That is not it there, but that is a challenge also. Data availability is another challenge. So for fine tuning, you need more data, but availability of that is a challenge. And that is that can be addressed using data augmentation, but there we have less number of techniques to do that. And causal inference in NLP.
I didn't wait.
Yeah. So what is the cause? How do you define this? Like that's another thing. Yeah. These are the different conferences that runs the world, different
205.
levels. ACL, NAACL. So yeah, if at all we publish something here, then it means the paper is really great. Okay.
22.
Yeah. So with this, let's break now. Let's take another 10 minutes of time, then come back. Is it fine?
Sure, sir.
Yeah, participants, we shall gather back at 3:15 p.m.
We have till 4 o'clock, right?
Yes, sir.
Okay. Okay, 3:15. Hello, all. Can you start?
Yes, sir.
Okay. Okay, let me again start with screen share of the PPT. Yeah, we were here. So before the break, we were talking about research works. Earlier, I was doing the demo of transformers. Then we were talking about the researchers and the main trend-setting researchers that have transformed NLP to a different level was discussed. And now we want to discuss about, I mean, not discuss, we want to do an hands-on of a how a machine learning model is built for NLP tasks. Okay, so the widely, as I was explaining in the first slide, so the widely used application in the industry is sentiment analysis. And it's a simpler one for us to understand as well. So I'm taking that as an example here to do hands-on with you. Okay, so we'll go slowly, and it's better if some of you can talk, but it's okay if not. Okay, so we would take another half an hour or so to do this hands-on. Then we'll go with other few slides. After that, Q&A. We'll make this last session like this. And what is next? Yeah, next is naturally governance is there. Yeah, I'll stop this sharing and go to the hands-on. Then share screen. Not this. Whole window. Okay. What do you see?
The notebook.
Okay. The notebook says sentiment analysis, right?
Yeah.
Yes.
Okay. So in the PPT, I was explaining you the various steps to build the model. Same, I just added here. Collect the data and explore it like what it does, then do the pre-processing and then feature engineering, then build the model and evaluate. So the last deployment part is not there because we are not going to do that. We are not going to deploy it anywhere for the end user to use it. So we will do all these steps. Clear? Okay. So first let's import the data. Before we import the data, let me show you that. Send input. This is the data set. Yeah, it has. So basically what it contains is a movie review and whether it says whether the sentiment is positive or negative. Zero binary value, so 0 or 1. Okay, that's all it is. So what we need to do is to, in future, if some movie review is given, we need to identify either whether that is positive or negative. That's all we need to do. So we will take this example, this whole data set, and then we will go through that. First thing, first let's read it. So IMDb data, maybe data for clearance. So I've imported all the necessary files, necessary libraries. So what we are going to use is like NumPy and Pandas is completely of basic, and NLTK is the whole sklearn related stuff are for the machine learning. NLTK is for NLP. Okay, so sklearn are for the machine learning purpose. So this is for the pre-processing. BS4 is for pre-processing. Okay, so that given that, we'll read it first. Read CSE. What is the file name? input slash im right, imdb data set, and then imdb data dot head 10. Okay, we read it. It's there in imdb data. So first 10. We'll read first one. imdb data of dot reviews of maybe 10th element. So this is what it is. So what it says, the Phil the Alien is the movie name, is one of those quirky films where the humor is based around the oddness of everything. Okay, so what does this movie is, what it sentiment, that also we can see. Sentiment, yeah, it is negative. Okay, would appeal to a stoner who is currently burning. Okay, so we'll do step by step all these steps and then see how it works here, so that you will be able to understand. So first we'll explore a bit of this data. So imdb data dot describe. I'm not going to do much. So it has 50,000 reviews with its sentiments. Almost everything is unique. There is only very less. So only 2 sentiments are there, positive or negative, and top are positive. So let's see how many are positive or how many are negative. Sentiment dot value counts. Yeah, it's equally distributed. Okay, 25,000 is positive and 25,000 is negative. That is cool. Okay, and I don't think I would need to. Do you think to do anything more? But let me stop here. So let's do pre-processing here. First thing is tokenization. I have that code handy. Some of the code handy is there because to save some of our time. It should load. Yeah, loaded. So first thing is, I mean, we used it, the tokenizer. We just loaded the tokenizer and we also loaded the stop word list. Okay, let's see what are the stop word list. Okay, it's a huge. Okay, there are list. Then what's next? Okay, HTML tag removal. For that we will use the beautiful soup. So we'll introduce a method strip HTML, add the text, and we'll use that BS4 soup. Beautiful soup of, it's an HTML parser because we need to remove the HTML parser, and we need to return the text bs dot text. It will get the text. What is it? It's a get text. Okay, just small method. Now let's see how it works with imdb data. String HTML imdb data dot review of 10. Get text of text that I removed. Text of yeah. So if you see all the HTML tags of that got removed. This BR are all removed, right? Yeah, cool. Then let's also remove some special characters here. Okay, for that we need a regex that is there above. two regex are there. These two bracket characters and then special characters. Let's quickly do one by one. Okay, I'll type definition, remove brackets, text, then return substitute. Yeah, does someone have any question? Substitute bracket with empty value. Bracket with empty value from text. Then definition, remove special chars. Again text. Again same, return re dot sub. Now this special characters, this regex. Again empty with text. Okay, let's try the same. Remove brackets, imdb data dot review of text. Right, okay, brackets are not there here, so nothing is getting removed. Then remove special characters. Yeah, now all the special characters like this are removed, right? Yeah, it's removed. Superb. Okay, so this first step is done. I remove special characters. Now our next thing is stemming. For stemming, we have, what are you using? Like we are using NLTK. NLTK stem porter stemmer is what we are using. So let's import that. Let's do that. Okay. Definition, stem text, again text. Okay. Porter stemmer equal to tk dot porter, right? Porter dot porter stemmer. An object got import and return it. So what we need to first do it is like we need to take the token for token in tokenizer dot tokenize text. In here, what you need to do, you need to stem it. So ps dot stem of token and collect every token and convert that to a sentence. And then return this. Yeah. You iterate, get the text, and then stem it, collect it, and yeah. Let's see how it works. Yeah, pretty good. It's tokenized and then removed. Which one I would say? Progress. Yeah. Joke. Yeah, like that. Eventually. Okay, that's what stemming is all about. That is good. What is like? I think we need to remove the stop word also, right? Is it there? Okay, maybe we also need to remove stop words. We also did it, right? Remove stop words. For that, we need a method. Maybe just above this definition. Remove stop words. Again, text. Let's again do the tokenizing. For token and tokenize of text. Then we don't need the last bracket. If token is not in stop word list, we don't need the stop word list now. Then collect it. How do we collect? Token dot collect it to tokens. Now make it as a sentence. Return join tokens. That's all. Okay, we'll test this also. Yeah, it's removed. IS is removed. Okay, I think all the pre-processing stuff are there, and we also saw how it works for each cases. Let's apply all of it on our IMDb data. So how do we apply? I'll do line by line. IMDb data of review equal to what we did first, strip HTML. HTML, or we can do other way. Review dot apply strip HTML. This way it's easy to copy. 1, 4. Okay. Remove brackets next. Remove special characters next. Hopefully you are all following. So if not following, then I mean it's boring. Then I can also easily copy paste and then do stuff. I wanted to do in front of you so that like all of you would be easily understand what I'm doing and ask questions if something. Hopefully this runs. Yeah, this is fully processing. Next is feature engineering. We will do feature engineering for 2, maybe bag of words and TF-IDF. We'll go those 2. I will find the code for those 2 for the faster purpose. This is bag of word. And TF-IDF. So if you see, it takes input as train and test, 2 different things. So we will add, we'll have to split the data then. So for that, I've added train and test here. Did I import? No, we have to import train and test splitter. After importing, let's split it. That is simple method. One simple method it is. Okay, what it does is like 20% would be test size, and then remaining would be train. And this is X, IMDb data review is X, and then this is Y, which is input and expected output X and Y. So then train test. Now megahertz, then TF-IDF. So I was explaining you the other thing. Y is, what is it? It's a positive and negative. So we need to convert that to 0 and 1 to make it to be an input for a model. So that this one is doing that. Label binarizer. It's binarize 0, positive to 0 and negative to 1. So we'll run that. Now we are at the model building step because we are done with feature engineering. Build model. So first, as I was explaining you, first is to see how it works with the basic model. We take that basic model as a logic regression. I'm just copying it. Let me know if you have any questions. Okay. Just initializing a model, and then now train. You are just training it by calling fit method of this model. And after that, you need to predict of each. Like we are doing two model, one is bag of words, another one is TF-IDF. And so next is predict. Then what we'll do, we will also see how accurate it is. And now we have, for test reviews, we have the responses. Let's see how it is performing for these cases. Y test and accuracy score. Okay, I need to print one by one. Yeah, for bag of words it's 60%, for TF-IDF it is 73%. Cool. So now that we also did for the basic model, let's move to the next level where we take few models and do model building and check how it is doing it. So I've created one method for that. Let's do that. Let me introduce that method. See here what I'm doing. Build the model and predict. I get all the data and first fit it, which is training it, and then predict. Then see how accurate it is. And what are all the models? They are only 2-3 models, smaller models. Then let's print. Let's do the work. what I'm doing here. So for bag of word, what is accuracy, and for TF-IDF, what is accuracy for the models like multinomial, logistic regression, and SGD classifier. Okay, let's print. Yeah, multinomial is good. It's better than 73. Logistic regression is same. Yeah, SGD is bad than logistic regression. So if you see, our base model is logistic regression. We compare it with other two. One is SGD and then multinomial. We see multinomial is doing better than logistic regression, and SGD is not doing better. I mean, doing lesser, worse than the logistic regression. So we discard these two and take multinomial as our multinomial ND as our multinomial naive Bayes. That's what the full name is. So as our model, and this model is will be used for our further enhancements. So as conclusion, we can see that we take the data and do all the steps here, like pre-exploration, pre-processing, feature engineering, and then model building one by one. Make sure like how we do it, and we also, and case to case it changes, like it's not the same number of steps, but this is very like toy project. Okay, so very smaller one. So for this, all the cases would be there, and then we will just showcase. You can also try it. IMDb dataset can be found. DD dataset. Maybe I can find the link and share. Okay. I'll again stop sharing. With this hands-on is completed, I will go with the slides and show a few, because we are left with another 15 minutes. So far, do you have any questions? Because it's hands-on, like you should have some questions. Okay. Then I'll go to the PPT. Play from current slide. So in how NLP works, we started with natural language understanding, then natural language generation now, and we saw a few demos. Now natural language governance. It's more about the legal bias and stuff. So these are the challenges: privacy and security, bias, ambiguity in the natural language is also that comes under governance because of the nature of the language, because some of the languages would be having more ambiguity than other. So you should not be discarding a language because of that kind of stuff. So that's why it's coming under the governance. And ethical concerns and legal and regulatory concerns, these are the main challenges. And some of the best practices that you can do is, like, you need to have principles to be defined before you even do, and government approval, what government says on your data model, and then how data is retrieved should be considered before you even do the model building and other stuffs, because natural language is directly concerned about data processing and stuff. Okay, so, and model needs to be continuously trained and then see whether it's working fine or not, or whether it's doing any governance violations or stuff like that. Then explainable NLP is straightforward stuff that says whether you are doing any violations. Okay, because you explain how feature is behaving and in what ways it is going away from the norms. So those can be found easily. So that's another thing. Yeah, so all three steps are done. So we are more or less at the closing stage. So future of NLP, that is, now we are more towards like ethics, explainable AI, and large language models and stuff. So slowly we will get into multimodal NLP. Anywhere you get the data and then process, that's what multimodal, and that is also is gaining popularity now. I was also explaining the quantum NLP. That's the future. In few years of time, we will also see what it is doing, and then many reasoning stuff. That's also getting popularized now. Let's keep going on. Yeah. Yeah, a few of the places where we can see really great potential is I mean, some places that I can highlight is ethical and fair, multilingual and low resource language support, and sustainability and green NLP, where like you use lesser resource to do your task. That's what green NLP is all about. Because CO2 emission is a talk everywhere. And academia, some of the things that I think would help in academia is what this all what I think. So automated literature reviews. I mean, if it can give you automated literature review, then nothing better than that. So at least my case, I took longer time to do literature review. Academic NLP for academic administration, and then multilingual and inclusive academia. This is another nice and important thing for me personally. Streamlining peer review and publishing. This is, I mean, the researchers would know the pain of peer review and time it takes. So if it is streamlined with NLP tools, then it's great. Yeah, that's it. This is what we can do. Academia finding focuses on finding new, whereas it's real world is so much what value you deliver. That's important. And mostly we work on benchmark data set. So but real world is totally different. And documenting the result is the outcome, whereas here is return on investment is the outcome. So these two are the way two different things. Yeah. So in summary, so I came to conclusion now. So in summary, what we were talking so far is like NLP enables the computer to understand and respond. Okay. That is to human being. That is the important step. That's what it does, and then it progress to a different level, different place to different level now. So it started with rule based system where dictionary based rule synonyms finding is the first thing, and now it can be so creative. So it grown so differently from there, and still we have so many challenges, and the future is really huge, and the potential of NLP is really bigger and bigger, getting bigger, and new places are being found, and new techniques are being found on a day-to-day basis, and learning this is really exciting, at least for us. I am done. Thanks everyone. Now I'm opening for question. So far, if you have not asked and if you would like to ask, you can ask. And let me stop sharing the screen.
Thank you, sir. Dear participants, you can ask your questions in chat box or unmute yourself and ask the question.
Sorry guys, I had to rush faster because I needed to give you some time to ask questions. That's why the last few slides were run. Yeah. Okay. I'll wait 2-3 more minutes or
Dear participants, please feel free to ask questions.
okay. So is anyone doing research now, or are all of you doctors already? I mean, did research already? Okay, it's Raghavendra, right? Raghavendra or Karthik? Who is the organizer?
I think we can wind up, sir.
Yeah.
Santosh, thank you very much for the comprehensive session on NLP. It was a privilege to have you in our FDP today. I hope our participants have gained a lot from the session of yours. Thank you, sir. Thank you very much.
Thank you. Thanks everyone for your time. Hope I didn't bore you guys. See you.
Certainly.
Thank you.
Thank you.
Bye-bye.
Dear participants, thank you for joining today. We shall meet back tomorrow. Thank you.